Hey everyone, welcome to this explainer. Look, if you're gearing up for a Google Cloud certification, you probably already know the high-level elevator pitch for most of these services. But here is a quick reality check. Passing the exam requires knowing a whole lot more than just what a service does. You need to know exactly how to manage it, how to deploy it, and crucially, which specific command line tool you have to use to make it happen. So let's dive right into this and unlock the Cloud Architect's toolbox.
All right, here's our roadmap for today. We're looking at 1. Relational databases decoded. 2. Navigating NoSQL offerings. 3. Analytics and big data. 4. Storage and messaging systems. 5. The command line toolbox. And finally 6. Acing the exam scenarios.
Okay, let's kick things off with Section 1. Relational databases decoded, transaction processing at scale. So, we've got two absolute heavy hitters when it comes to managed relational transaction processing. That's Cloud SQL and Cloud Spanner. Now, both of these use SQL to query data, right? But they serve entirely different scales. Think of Cloud SQL as your fully managed workhorse. It's going to handle those regular scheduled backups, it tunes the OS automatically, basically it does the grunt work so you don't have to. Cloud Spanner, on the other hand, that is your go-to for global, massive scaled data. And what's kind of wild about Spanner is how it actually initializes. You can't just, jump right in. You literally have to create the instance first, then the database inside that instance, and only after that can you actually create the tables to hold your data. And listen, this brings us to a massive exam gotcha. If a test question ever asks you how often a database administrator should apply security patches, or, say, use apt-get to update VM packages on Cloud Spanner, the answer is literally never. Why? Because it's a fully managed service. Google is taking care of the underlying compute resources and the OS tuning for you. Seriously, do not fall into the trap of volunteering to do work that Google is already doing.
Moving right along to Section 2, Navigating NoSQL Offerings, Flexible and Wide Column Storage.
All right, let's step away from traditional tables for a second and look at where flexibility and just immense scale really take over. This is where we pit Cloud Firestore against Cloud Bigtable. Cloud Firestore is our document NoSQL offering. It's super easy to add small amounts of data through the console. And get this, if you're using it in data store mode, you actually query it using a SQL-like language called GQL. Now, Bigtable is a completely different beast. It's a wide-column NoSQL database that does not support SQL whatsoever. Instead, it's custom-built to ingest just massive volumes of streaming data. We're talking heavy Internet of Things scenarios, like thousands of smart meters reporting data every single second. It is a workhorse for streaming.
Next up, Section 3, Analytics and Big Data, Processing Petabytes.
Okay, now we're shifting to the absolute heavy lifters of the cloud. These are the tools built for data warehousing and hardcore analytics. So let's nail down what Cloud Dataproc actually is. Imagine your department needs to analyze massive batches of transaction data every single night. Or maybe you need to run some heavy extraction, transformation, and load operations, ETL. Well, Dataproc is the explicitly managed Spark and Hadoop service built exactly for that kind of heavy lifting. And as a bonus, through Spark, it gives you a fantastic environment for machine learning too.
And then, of course, we have BigQuery, our petabyte-scale analytical database. But look, working with petabytes means you really need to watch your wallet, right? The exam absolutely loves to test how you estimate costs here. And it's a very strict two-step process. Step 1, when you enter a query, you need to look at the query form to see the estimated amount of data scanned. Why data scanned? Because BigQuery charges you based on the data scanned, not on how long the query takes or the network I/O. Then, step 2, you take that scanned data volume and plug it straight into the Google Cloud pricing calculator to get your actual cost estimate. Boom, done.
All right, Section 4, Storage and Messaging Systems, Moving and Holding Data.
So, let's introduce the systems responsible for keeping your objects safe and, more importantly, moving messages reliably between your distributed applications. Enter Cloud Pub Sub. This is a super robust message queue system. I like to think of it like a highly reliable digital post office. If you're building a distributed app that really needs to be resilient to failure, Pub Sub is your best friend. Your applications write data to core components called topics, and then consuming applications receive those messages through subscriptions. And those can be configured as either push or pull. But the real magic of Pub Sub for resilience is its retention period. Unread messages are actually held for a specific period, say 3 days, before they're finally discarded. So if an application temporarily goes offline, you don't lose your data. It's an absolute lifesaver.
Moving into Section 5, the command line toolbox, the command line trap.
Okay, we're at a major pivot in this explainer. Look, if you've ever banged your head against a keyboard because a deployment command just refused to work, you're going to feel this one. Assuming the default command line works for every single service is literally the biggest trap on the exam. To avoid it, you've got to memorize 4 distinct tools. First up, gcloud. And yeah, it is used for most products, Cloud SQL, Spanner, Firestore, but absolutely not all of them. Second is gsutil. This one is exclusively for cloud storage operations. We're talking moving objects, renaming them, rewriting storage classes. Third, BQ. If you're doing anything with BigQuery from the command line, like operations or dry runs, you have to use BQ. And finally, CBT. This is your dedicated tool for cloud Bigtable table creation and management. Let me be clear, assuming gcloud works for Bigtable or BigQuery is guaranteed to cost you points. Don't do it.
And finally, Section 6, acing the exam scenarios, applying your knowledge.
All right, let's see how all of this builds your intuition. I'm putting you in the hot seat to test your pattern recognition with some simulated exam questions right from our source text. Ready? Here's your first scenario. You need to run an automatic backup at 3 a.m. on a Cloud SQL instance called ACE Exam MySQL. Take just a second. Think about the service and think about which CLI tool manages it.
Let's eliminate the distractors together by spotting those CLI patterns. CBT SQL? Nope. We know CBT is just for Bigtable. BQ gcloud SQL? Total nonsense. BQ is strictly for BigQuery. Okay, what about gcloud SQL databases patch? Ooh, this one is sneaky, but it's wrong. You patch instances, not databases. Actually, scratch that. You're applying a backup patch to the instance itself. That leaves us with the correct structure right here. gcloud SQL instances patch, followed by your instance name and the backup start time. See how that works?
Let's try another one. What is the correct command structure to estimate the volume of data scanned by BigQuery, specifically from the command line? This one perfectly reinforces that command line trap we just talked about. gcloud BigQuery is wrong right out of the gate, because gcloud simply isn't the primary tool here. gsutil query is out because, remember, gsutil manages cloud storage. And CBT BigQuery is obviously wrong because CBT is solely for Bigtable. So by just crossing those out, we immediately prove that BQ with the --run flag is the only valid answer. And it makes sense, right? A dry run perfectly estimates the data scanned without actually executing the query and, charging your account.
Moving right along. Time for a quick-fire question. You want to rename an object stored in a cloud storage bucket. What command structure do you reach for?
Okay, first things first, we're in cloud storage, which means gcloud is the incorrect tool, period. We definitely need gsutil, but watch out because the exam is going to try to trick you on the actual verb. gsuit CP is just for copying an object. If you want to actually rename it, you're effectively moving it to a new name. So the correct verb is MV. Therefore, your correct structure is gsuit MV, followed by the old object path, and then the new object path. Simple as that.
All right, last scenario. We're stepping back to look at the high-level architecture here. Imagine an executive emails you asking for a recommendation system that will help sell more products. Classic request, right? Which Google Cloud service is the absolute best fit for building this out?
Let's contrast our options for a second. Now, Cloud Spanner and Cloud SQL, fantastic, incredibly powerful relational databases, but they don't natively support the kinds of complex machine learning algorithms you'd need for a smart product recommendation system, so cross those out. That leaves us with Dataproc. But wait, do we use Dataproc with Hadoop? Actually, no. Hadoop isn't really ideal for ML. The winning architectural choice here is Cloud Dataproc, specifically leveraging Spark and its built-in machine learning library. That is how you lock in the right solution for that executive.
So when we look at all this, what's the core philosophy you really need to take away from this explainer? Honestly, it's pretty simple. Choose the right tool and the exact right command line for the job. If you can recognize the boundaries of managed services, the specific use cases for NoSQL, and map out those rigid CLI tools in your head, you are going to easily navigate even the absolute trickiest questions on this exam. We have covered a ton of ground today, breaking down everything from global relational databases to the very specific subtleties of command line tools. So I'll leave you with this. Now that you know the tools and the traps, which Google Cloud service are you going to master next on your path to certification? Dive back into your study guides, take this framework, and apply it to whatever you tackle next. Keep learning, keep organizing that knowledge, and I will see you in the next explainer.